So, unless you've been living under a rock or something, you've probably heard of this thing called Claude or Gemini or even ChatGPT. But if for some reason you have no clue what I'm talking about, it's basically an app where you can ask it pretty much anything and it'll respond to you like it's a human. And it raises some pretty big questions, like will it erase humanity and how does it work? The answer to the first one is probably, but the answer to the second one is a little bit more complicated. And to break it down, we need to think of it not as a super smart computer with a brain, but like any other AI model with the ability to detect patterns. And before we go any farther, we're going to be referring to these AI models like ChatGPT or Gemini or Claude as LLMs, otherwise known as large language models. Like any other AI model, an LLM needs an input, and in this case, it's the prompt, the thing that you write to get your response. But here's the interesting part. It predicts what it's supposed to say next. It'll use a mathematical system that uses past data to calculate the most likely next outcome. Take, for example, the autocomplete on your keyboard. When you type, "I'm going to the blank" on your phone, your keyboard might suggest store or library or something else. And it's not reading your mind, it's just a tiny predictive model. It looks at billions of texts that people have sent before and calculated that store is statistically the most likely next word. An LLM is doing the same math, just on a bigger scale. So an LLM doesn't actually know what it's saying. It's just a mathematical system that predicts the next word. So this completely breaks the idea that it's able to think for itself. Now that we understand that an LLM is just a predictive model, we can move on to another concept called tokenization. So to understand tokenization, you must understand that computers can't actually read English. They read numbers. You've probably heard before that computers understand binary language. Well, LLMs work in a similar way. So LLMs take an entire sentence and then chop it up into little pieces. And then it gives each little piece an ID, which is otherwise known as a token. LLMs don't split up tokens by words. For example, the word unbelievable would be split up into 3 tokens. You might be asking yourself, why not just give every word its own number? Well, the answer is pretty simple. The human language is infinite. Think about typos, slang, code snippets, every name on Earth. If the AI had to memorize a unique number for every possible word, it would run out of memory very, very quickly. Tokens are kind of like Lego bricks. They break up the human language down into around 50,000 to 100,000 subchunks. And then the AI can use those subchunks to create any word in existence, even words that don't exist. This is much better than having token IDs with hundreds or even thousands of digits. So these tokens act as the input and the output, basically translating English into mathematical language. However, a token is just a single ID number like 328. By itself, the number means absolutely nothing to the AI because it doesn't know what it means. To give it meaning, the AI converts that single ID into something called an embedding. It's a long list of hundreds of numbers. You can think of these numbers as coordinates. Because the AI was trained by reading billions of sentences, it figured out a pattern. Words that are used in similar ways should be grouped together. For example, let's just say that you have every word in the English dictionary labeled out on a 2D grid. Words like bank and vault would probably be really close together, but words like apple and vault would be pretty far apart. The coordinates of each word would be called an embedding. But an AI model doesn't just look at embeddings in 2D or even 3D. It looks in hundreds of dimensions. This is how the AI understands language. It doesn't actually comprehend words, it just calculates which lists of numbers, otherwise known as coordinates, are closest together. Because every word is just a point on the graph, you can add or subtract embeddings, otherwise known as vectors, to get different words. For example, if you take the coordinates for the word king and then subtract the coordinates for the word man, then add the coordinates for woman, the exact point that you land on the multi-dimensional space is the word queen. AI doesn't know what royalty is, it doesn't know what gender is, it just knows how to trace the mathematical distance between concepts. Now that we understand what embeddings are, let's move on to the transformer. And no, I'm not talking about the movie. So before the transformer, whatever that is, was invented, AI read sentences like a human, one word at a time, from left to right. The problem was, by the time it reached the end of a long paragraph, it would forget what the first sentence is about. Kind of like us. Or maybe it's just me. So what the transformer does is it just processes the entire chunk of text at the same exact time. Think of it like an entire boardroom of 1,000 analysts. They all read their assigned words at the exact same millisecond. For us, this would never work because we can't process everything at the same time. But for the AI, it's actually perfect. However, if it reads everything at once, how does it know which words are actually connected? This is what the attention mechanism fixes. When the AI processes a sentence like, the bark on the tree was brown, the word bark is ambiguous. To figure it out, the attention mechanism runs a calculation comparing the embedding of bark with the embedding of every other word in that sentence. It assigns a mathematical weight, think of it like a percentage, to every connection. It gives an 85% connection score to the word tree, a 10% connection score to the word brown, and a 0% connection score to the word D. By looking at the percentage scores, the AI shifts the meaning of the word bark away from dog and closer to wood. It does this calculation for every single word, all at the same time, giving it perfect context. Now that we understand how an LLM processes a prompt, let's move on to how an AI model like ChatGPT is actually made. So the first step in training an AI model like ChatGPT is called pre-training. Think of it like sending someone into a library and then forcing them to read every single book, newspaper, or internet forum ever written. This takes thousands of computers months to process. At the end, the AI understands grammar, facts, math, and how to speak. However, there's a problem. It's basically just a giant autocomplete engine. If you prompt it with, how do I bake a cake? It might respond with, how do I bake a pie? Because it saw lists of questions like that on Reddit. It knows everything, but it doesn't know how you want it to act. This is where a process called fine-tuning comes in. It takes a highly educated model and gives it a much smaller, highly curated set of specific examples. You can show it, when a user asks a question, you reply with a helpful, formatted answer. You aren't teaching it new facts necessarily, you're teaching it a persona. Fine-tuning is the exact step that turns a wild, unpredictable text predictor into a polished, helpful assistant. Even though an AI was trained on the entire internet, its memory with you when you chat with it is strictly limited. This is called the context window. For example, say that you're prompting to ChatGPT. ChatGPT might remember what you say at the beginning, but after you prompt too much, it'll forget what you said at the beginning to make room for new information. It's like the saying, out with the old, in with the new. Alright, let's move on to another limitation called hallucinations. You've probably heard of these before, but let me just give an example. I'm sure you've been on ChatGPT one day and asked it to write like a research paper or something. And when you asked it to write sources, and then when you check the sources, none of the links work. And the citations are completely made up. Or maybe you ask it, who is the president of Mars? Obviously Mars has no president, but it still might respond to Abraham Lincoln. These hallucinations happen because AI is a predictive model. It might predict the next word, but it doesn't mean that the next word is actually going to be true. It might predict something that sounds realistic, but it doesn't mean that it's going to be factual. And that's pretty much it for LLMs. Now, the world of AI is always expanding. It seems like every other week there's a new model update, a new AI startup being launched. So if you want me to make more videos about AI, please leave a like, subscribe, and be sure to comment down below.